All right, so AP Calculus Lesson 1-1. Let me move the participants window. Today's date is Tuesday, August 25th, 2020. All right, and I don't think, I'm trying to figure out a way to make this fair. Everyone's pretty good about using the Zoom tools to raise their hand, so let's be using that for this whole lesson and see how it works out. I don't know how to feel about it yet. With a Zoom raised hand, or I guess maybe you can raise your hand in your camera, whatever you want. Who wants to read our objective today? And thank you, Andrea.
Evaluate left, right, and double-sided limits from a graph.
Perfect. There it is. All right. So left. What does the left-hand limit notation look like? This is what you're going to be copying down with me. It looks like this. It's the limit. So LIM. And then you want to say, where are you going to in terms of left and right? What x coordinate are you approaching? So it's x is approaching some number. It could be 5, 6. In this case, I just chose the number c. So it's going to be c. And from the left is going to be kind of like to the power of minus sign. I should have written the f of x first. So the limit of f of x as x approaches c from the left. And I know that there's a lot of stuff to copy down, but I'm going to read that one more time. The limit notation for the left limit is the limit of f of x as x approaches c from the left. All right. Is there anyone that wants to attempt how to do the right-hand notation for the limit? Yeah, go for it, Fiona.
The limit of f of x as x approaches. And then isn't it c, like just c?
So just like that, just c.
Yeah.
You're really, really close.
Or
If
just
left
being
is negative, right would be, yeah, exactly, positive. All right, and then what about for both sides? So it's between Teflon and Chris. I want to make sure that everyone participates right from the get-go. How do I limit from both the left and the right? What would be your guess? Who's it going to be, Teflon or Chris? And then whoever doesn't participate is going to be forced to do it next time.
I feel like I remember it, but then I don't.
Go for it. Yeah, give it a shot.
Mm, yeah, I don't remember.
Okay, we'll start out the same way that all of these have started out, right? How do you say this thing?
Limit of f of x.
Exactly. So limit of f of x. And what is going to be the bottom?
X
As x.
approaches
Yep.
c.
C. And what symbol are you going to be using?
I don't know.
If you had to take a guess, what would you say?
2.
Two. That's a good guess. Like it from both sides. So from the left and the right, there's two sides, right? No, that's a good intuition. But actually, we're going to try to keep it as simple as possible. We're not going to put anything there. I mean, some people might think, oh, plus and minus, that might be it. But no, it's going to be nothing, which is kind of confusing, actually. So both sides is nothing, which means the simplest version is the most complex. It's both the left and the right. So just be careful whenever you see a number without a plus or a minus in like for the rest of AP Calculus, that is the harder version of the limit. Okay, so my first limit, let's do this. Go ahead and just draw some sort of wavy graph. It does not need to look like this exactly. I just drew a random graph, a random point, and then underneath that point, I said, okay, that's the spot C. This is the C that we've been talking about in these three spots. So some random graph, I'm gonna call it f of x because all of these are talking about f of x. And again, this can be a sketch. It doesn't need to be exact. I think for most of these graphs, like down here, I'm gonna eventually have a graph that can be sketched out too. They don't have to be perfect. All right, so I have a few intro problems for you for limits. The first thing that I want to do for number one down here, I mean, you're still copying down, so that's why I'm taking so long to talk. The first thing that I want to do is I want to be able to say these things. Can you pronounce this? Can you pronounce number 1, 2, 3? How do you say those things? And then after we know how to say those things, let's actually discuss what they mean. So I know you're still writing down. This is me giving you some time. Okay, so let's try this out. Chris, you're up first. How do you pronounce number 1? How do you say this thing? I don't want you to say LIMX arrow C to the power of negative. How have you been pronouncing these just up above?
Limit of f of x, right?
Perfect. Keep going. Yep.
Approaches c to the left, or how?
C from the left. Yeah, exactly. No, you got it. Yeah. So the limit of f of x as x approaches C from the left. Okay. So we're getting closer and closer to this x coordinate. So whatever this x coordinate is, another way of thinking of this graphically is the x coordinate here is C. So if I'm thinking of a line here that goes through that x coordinate, let's move that line right here. So this is the x coordinate. As I get closer and closer to this x coordinate, I don't know what the height is going to be. And that's what this limit is asking. The limit is saying, hey, what is your height? What y value are you approaching as I get closer and closer to this line towards this x value of C? By the way, this line that I've drawn here is the line x is equal to C. It's not that important, but as I get closer and closer to this line, this wall, have you, what is the y coordinate? That's the question that I'm asking here. So what y coordinate does it look like I'm approaching? And I'll give you a hint by drawing a nice straight line. What is the answer to this question? The question is, what is the y coordinate? I can even write that. This is writing what is the, I cannot spell, oh my gosh, what is the y coordinate as you approach that value from the left? Anyone quite raise your hand? I'm looking at your cameras too, so you can raise your hand actually with your camera, or you can raise your hand with Zoom. Somehow raise your hand and then you can get called on. What height am I approaching as I come from the left? So here's me coming from the left. I started over here, I'm going this way, this is from the left. And eventually I'm getting closer and closer to this yellow wall over here. What is the height, Fiona?
5.
5, exactly. So the answer here is 5. Thank you. And I'll write left for these green arrows. All right, I need another quiet raised hand. Again, you can use just your camera or you can use Zoom because I'm looking at your cameras. What about this one? How do I read this problem, this number 2? How do you say this thing? Who wants to give it a shot? We'll give it to Andrea. Sorry, Tevon, a little bit late.
What's the limit of f of x as x approaches C from the right?
From the right, perfect. So I'm going to come back up to my graph. From the right means I'm coming from this far right-hand side. I'm going this direction from the right. All right, this is from right. I should write from, so it makes more sense. This is from the left. So from the right, as I get closer and closer to this x coordinate C, to this wall here that exists at C, what height do I approach as I come from this side? I'm going to give it to Teflon. She had her hand raised. What height do I approach? And don't overthink this.
Isn't it 5 also?
It is also 5, exactly. Because you can see as I get closer and closer, I get like pressed up right against this point before, and I don't care what happens at this point. And that's a clarification I should have made before. I don't care what the actual height is. And can we all like write that out in all caps? We don't care. About, I should use all caps, about the actual height. This is the most, I can't spell. This is the most common mistake when doing limit problems is sometimes they'll do like an open dot here and maybe a filled in dot down here. They're like, oh, look, the filled in dot down here has a height of 3. No, I don't care what happens at this, like wherever this line is, this wall. I don't care what's happening at that wall. I only care as I get closer and closer to the wall without actually touching the wall. That wall is an electric fence. I can't touch it. I can get closer and closer and closer and closer to it, but I can't ever get there. That's what the limit is stating. All right, and then number 3, how do we read number 3? Number 3, I'm gonna start cold calling on people. We're gonna go for Teflon again. How do I read number 3, Teflon?
Limit of f of x.
Perfect, keep going.
Approaches C from both sides.
From both sides, there it is. Well said. All right, so this is actually easy to do. It needs to be whatever these two values are. So if this is 5 and this is 5, automatically you can say, well, this is also 5, just based on limits. If I didn't even see the graph up here and I just saw only this information and it asked me this question, oh, well, I just take these two values and the answer is 5. But also graphically, what's going on? It means that, well, what happened there? It means that as I get closer and closer to the wall, that the right-hand side is getting to the same height as the left-hand side, which might not happen. And I'll show you in a case where that doesn't happen in a second. So I'll write over here, right and left have to match. Otherwise, I can't spell otherwise. This is a D-N-E, does not exist. If the left-hand limit is 4 and the right-hand limit is 9, the limit for the double-sided limit is D-N-E. There is no limit. All right. So my challenge for you right now, and again, you don't need to copy down every single thing for the notes because it's going to take too long. I want you right now to just draw a simple graph. Can you draw on that graph some sort of curve where the left and the right limit are not the same? I mean, I drew one that is the same. Look, the left limit and the right limit, they hit the same point. But can you now draw some sort of curve? And you're allowed to pick up your pencil. Can you draw something where the left limit and the right limit is not the same? And if you haven't seen it before, it is a little bit difficult. And if you think you have it, go ahead and hold it up to your camera. Or be ready to describe. Again, if you're writing out this question. It's kind of a waste of time. You don't need to say, can you draw a graph? Go ahead and just draw the graph and see if you can do it. Spend more time doing the thinking than the writing as much as possible for your math classes. All right, so does anyone think that they have it? If you have it, go ahead and, or if you think you have it, go ahead and show it. Hold up your camera. I'm curious what you guys are seeing. This is one of the things I hate about Zoom the most. I want to be able to look over your shoulder because you might not have confidence in yourself, but I'm so curious on what you guys are trying to draw right now. No? No one? Let's see. Yeah, Fiona, what do you got? Okay. And what point are you going to take the limit to? Can you go ahead and just draw a point on that graph somewhere? Which point will have a limit on the left that does not match the limit on the right?
Wait, can it be 2 points?
So you have to choose one point because I guess I didn't explain that very well, did I? We're trying to do the same two questions right here, where these two with the same coordinate C have different answers over here. I'm sorry for that miscommunication. I should have stated that better. Okay, it looks to me that as I go from the left, I get to that negative height, and as I go from the right, I get the same negative height, so not quite. And my hint for you guys is you are allowed to pick up your pencil.
That's what I did.
Maybe, can you hold it up again? Did I just miss-see it?
I don't know if you can see it good. There's like a gap, like right there.
Oh, okay, then that might be correct. It's still kind of, it's like this big on my screen. That might be right then. Let me go ahead and show you guys a few different answers that you could have put. So let's do one where I'm just gonna do a straight line because curves are hard. I'm gonna do a straight line that just ends right there and then just, I don't know, starts again down here. For this blue line, I'm gonna go ahead and obviously say that the line that I'm trying to look at is this x coordinate -3. As I go from the left, I have a height of 2. As I go from the right, I have a height of 0. 2 and 0 obviously don't match. As I approach this wall, my height, my y coordinate, is not the same. I can draw another one if you'd like. Let me do this one. So I have some sort of, I'm going to do a curvy function. I have some sort of function that goes up like this and some sort of function that goes down like that. So you can probably tell that this has, I mean, this red function can go out here forever and ever and ever. This red function can go out here forever and ever. But at this point 2, what is the limit? What height do I approach at this wall here at x equals 2? And you'll see, well, it never touches the wall. All of the examples I've had so far touch the wall. It touches the wall. It touches the wall. Here's a wall where it never touches it, which is sometimes okay. You can sometimes say, well, they both go up and up forever, so the limit, they both go towards infinity. But this one is not okay because this one seems to be going from the left over here. From the left, it seems to be going towards positive infinity, and from the right over here, it seems to be going down here towards negative infinity, because positive infinity is not the same thing as negative infinity. This is also a D and E for the double-sided limit. And I mean, there's like a ton more examples I can show you. We'll see those more in the future of this unit. I just want to get your heads, your brains used to the idea of there's a lot of times where you'll have some sort of curve where the left limit and the right limit are not the same.
So like that.
It's still really hard to see. I'm sorry. I think I would have to stop sharing my screen to see it better.
That's okay.
Okay, so I'm going to come down here now. So this is one of my examples of where limits are not the same. And I'm going to ask you some questions about it to make sure you have a solid understanding of single-sided and double-sided limits, which is our objective today, right? So first of all, I want someone to read number 1. I'm just going to go ahead and cold call to make this go faster. Go for it, Chris. How do you say number 1?
As x approaches -1 from the left?
From the left, exactly, yeah. So that limit of f of x, and oh, Mr. Sindel, you've made a mistake. Okay, I'll make this change for next time. These should all be g of x. I'll change these all to g of x, because notice that the function up here is not f of x, it's g of x. It's a tiny little mistake to make, but it's still worth correcting for next year. So yeah, the limit of g of x as x approaches -1 from the left. So let's go ahead and draw a wall. Again, the point that you're evaluating at, that's going to be our wall. So we're drawing a wall here at -1. So let me go ahead and draw a line that's nice and neat. There's my wall. As I get closer and closer to that wall, what is my height going to when I approach it from the left is the question. This is from the left. From the left. And it's pretty clear that the answer is what? Someone else. As I go from the left, I have what height? What y coordinate do I get? Teflon, yeah, go for it.
2.
2, exactly, yeah. This height here, this y coordinate is 2. So I come down here and say the answer to this question of the limit is 2. All right. I'm going to give this to Andrea. How do you pronounce number 2?
The limit of f of x as x approaches -1 from the right.
From the right, exactly. So I still have that wall drawn. That's my suspect point, I suppose you could say. This thing that I'm trying to figure out, and I'm going to the right now, from the right. So from the right, I'm going this way, this way, this way. I'm going down, down, down. And this is from the right. So from the right, as I get closer and closer to the x coordinate, -1, what is the y coordinate approaching? And I don't care what happens at this point. I don't care what actually happens. I only care what I'm approaching. And what is the answer? We'll give it to Fiona.
-1.
-1. And I realize I'm going too fast because this problem you kind of want to copy down the graph exactly. We're just starting to run out of time because I still need to talk about homework. These notes, filled and blank, are still available on the website. So the last question that I have for you before I release you for the homework is this one. Anyone, first come, first serve, with a raised hand, so of course. How do you read number 3? Fiona. Oop, sorry. I muted you by accident. I thought you were already muted.
The limit of, would it be g of x?
Limit of g of x.
G of x as x is -1 equals.
From
Both sides.
From both sides, exactly. Yeah. Whenever you don't see something, that's the hardest one. Perfect. So Fiona read it correctly, and now we have to figure out what it is. So these two have to match, otherwise, and they don't match. So otherwise, the answer is what? First come, first serve. Andrea?
Does not exist.
Does not exist. Does not exist because they didn't match. Okay, so you guys have the basic understanding of one-sided and double-sided limits. And there's a little bit of the homework that's talking about tables just to get you in the idea of what is the y coordinate or the f of x approaching. But I think we have 3 homework assignments. And I was battling against this all last night on what to do for homework, because normally my homework is always on paper. It's always been on paper, but the homework, if I did it on paper tonight, you would spend 80% of the time copying down the homework and then 20% of the time like actually thinking about the homework. And I hate that. I want you to be doing more thinking than writing. So I decided to do Khan Academy, which no, it's the best in the bad situation. So it's still not the best, and I'm sorry, and I was trying to move away from it. but it does sync up pretty well with the curriculum that I'm using. So you guys should all see, if you log into Khan Academy with your account that you use for Google Classroom, because I linked them together. So if you use that same account with Google and go to Khan Academy, you should see 3 assignments there that are related to the notes that I just did. Some things might be a little bit tricky at first, but everything does come from the notes. I can pull up one of those examples too if you guys would like. Let's go through one of them together. Again, these notes, I'm going to go ahead and save them right now so they're automatically uploaded to the website. Sharing window is closed. Oh, it isn't. It's still open. Limits intro. Let's do a few of these really quickly together. Or if you want to ignore me and do the homework, that is totally fine by me because you want to get this stuff done. All right, so what is a reasonable estimate for this limit? And it's kind of hard to see. I can zoom in a little bit. It doesn't have any plus or minus next to it, so it's a double-sided limit as I get closer and closer to 3 of this function. As I get closer and closer to 3, it seems to be approaching the height of -4. So I'll do this one. Someone else do the next one. So this one is -4. Everyone can see the graph, see the question. We're good. All right, someone else do this next one. This one is a table value. So I get closer and closer to the value of x goes to -2. So -2 is right about here. What is a reasonable estimate for chi of x? As I get closer and closer to -2, what do you think the answer is? Closer and closer to -2. You can raise your hand. I see your cameras. Yeah, go for it, Andrea.
8.
Yeah, exactly 8, because 8 is in between 8.02 and 8.03. The answer is 8. Let's see if someone else can do another one. What is a reasonable estimate as x goes to 0? This one's a little bit trickier. As x goes to 0, so that's right here. You know where to draw the wall. What should I be choosing out of these 4 choices? As x gets closer and closer to 0, what should I be choosing? Yeah, Teflon?
Would it be the last one?
Yes, does not exist because it approaches 5 from the left and -5 from the right. So they're not kind of going together, so perfect. And last one before I leave you guys, you still have 1 minute and 10 seconds left. As I go closer and closer to -1, Chris, you want to do this one?
No.
You got this. -1, what do you think the height is approaching?
Wouldn't it be DNA or does not exist either? Also.
Explain why. Because it's a little bit tricky, so I want to hear your thinking.
I don't know.
It seems like you might say it does not exist because there's this point up here at 4, and then there's the line down here at -3, right? So it seems to be diverging. So this is one of those times where you want to kind of ignore what's happening at that point. So if I can do my draw tool, so my line, my wall that I'm drawing right here goes through that point. Anything on the line, I don't care about. Ignore the fact that there's a point up there. So everything on the wall, I don't care what happens at that point. I only care what's happening as I approach it. As I approach that x squared -1, as I approach the x squared -1, it seems to be going to the same point from the left and the right. So the answer is not D&E, it's something else. What would you guess?
-3?
-3, exactly.
Sure.
Cool. All right, I'm 10 seconds over. That's it. We have 3 homework assignments. Good luck. Message me with questions if you have them. I'll see you tomorrow.